The Pathways to Knowledge model of information processing identifies 6 stages that students go through when learning to process information. They are appreciation, pre-search, search, interpretation, communication, and evaluation. More information on this can be found in the Technology as Facilitator of Quality Education model. The students in this 8th grade science class are learning about weather. The teacher first reviews the assignments and lab work students have already completed during their weather unit. The students demonstrate the appreciation stage of information processing when they discuss how the software tool Model It helped them understand the interaction of the different factors that affect weather.
Okay, what's the purpose behind Model It? Who can remember that? Who can tell me? Corey.
So that we can kind of brainstorm all we know about the subject and put it on, and like put it all down on Model Builder.
And their relationships.
And have the different relationships, and so we can see hands-on stuff.
So you can create your own models and show the interaction between the different objects in nature, how they affect one another, so the relationships. What does Model It, though, provide for you?
Well, you have control of the direct or indirect relationships.
Yeah, you can modify all the variables right there.
And you can see how it will change.
Without having to imagine it, it shows you.
Great. Without imagining it or waiting for it to happen, you can show how it should happen. So you could possibly predict.
The students demonstrate the evaluation stage of information processing when they evaluate the weather models they have created using Model Builder. This gives the students the opportunity to assess their personal information process and check for effective communication of new knowledge before they present to their classmates.
Okay, let's actually try and figure out a way we can actually explain this.
Doesn't the time of day affect the temperature?
Yeah.
So we should have a relationship between
in the morning, the temperature is low. In the afternoon, the temperature is weak. And at night, it's high.
Okay, time of day affects the sunlight because there's sunlight in the
Yeah, but it already is
high, and then when the sunlight, it gets hotter when the temperature goes up, and when the temperature goes up, the chance of rain goes up. Wait, no.
Necessarily.
Goes down.
No, not necessarily.
Yes, because when
There's no bearing on the temperature. There's no bearing with the temperature of rain.
Yes, because when it gets colder, relative humidity goes up, and when relative humidity goes up.
And to G weather?
So should we start by
G
making
weather
a,
Model It?
See, the temperature goes there, and once the relative humidity goes down, the chance of rain goes up.
So it does or does not make sense.
Okay,
G
but
weather
huge
model.
holes
It's
in
in
the thing, but that's
so should we make a relationship between these two?
Oh yeah, let's put it in.
no. There's already a
You
relationship.
mean it's not on the
Between time of
desktop?
day and temperature?
Yeah, because time of day,
Oh,
there's
yeah.
more sunlight, and when there's more sunlight, it goes to temperature.
Just transfer it over.
2 students demonstrate the communication stage of information processing when they present the weather model they have created. The students organize information for their presentation. Then they present new knowledge about barometric pressure and the sun, expressing ideas through a computer presentation.
Model, we made it so if you have high pressure,
You have to speak louder, hon.
if you have high pressure, the pressure goes high, and then also the precipitation goes up higher. I mean, goes lower because
Same with the clouds.
and the clouds go lower because in high pressure you can't have clouds
You can't evaporate.
or humidity because you need low pressure to have humidity. So the clouds and this is the yellow is the precipitation
And the green is humidity.
yeah, so they both go low. And if you lower it, they sort of
That's
switch
opposite, yeah.
because they're in close relationship. And the humidity and the precipitation goes high if we lower the barometric pressure.
So if you lower barometric pressure, then you have more clouds, and because of more clouds, more moisture.
Yeah.
Okay.
Alright, then if you raise the amount of sunlight, what's going to happen is the wind's going to raise because by raising the amount of sunlight, you raise the heat, it makes it more uneven, like the heating and cooling, which will cause wind. So
the pink is the wind, and it goes up higher when you raise the sunlight and the heating and cooling.
Okay, that makes sense, because what did we say? We said that wind, one of the things that cause wind is
uneven heating of the surface of the Earth.
Sure, because the Earth wants to do what? It wants to
Be equal.
be equal, right? Equal pressure and equal temperatures, okay? Great. Where is an area where we don't have much wind?
The doldrums of the equator.
Okay, at the equator. And why might that be?
Because of the sun, always since it's in the middle of Earth, the sun shines on it an equal amount of time throughout the year. So it's pretty much getting an equal amount of heat each day.
So there's very little variation. Oh, great. All right, any other factors? All right, that looks good. Does anybody have any comments or anything to add to their model here? Okay, so your question was pretty much centered around how barometric pressure and sunlight affect different weather conditions. Okay, great. Thank you very much. Okay.